Hi, welcome back. In this last section, we're going to do numbers 9 and 10 of the Unit 3 portion of the review. We're going to find the value of x in the figure below for number 9. Okay, I can see I have a tick mark here and a tick mark here, so that means I have a leg and a leg. And when I look at my two legs, I know that they have the same measure, and since it's isosceles, I know I'll also have two congruent angles. And those angles will be along the third side, which is my base. So I know that this angle and this angle will be exactly the same. So if this one is x, this one is also x. Okay? Now, if we want to do this algebraically, I'm going to use my triangle sum theorem that says the three angles in the triangle, 56 plus x, add up to 180 degrees. So when I combine my like terms, I have 56 plus there's two x's equals 180 degrees. So then, there we go. I'm going to use my subtraction property of equality to subtract 56 on both sides. And 2x equals 180 minus 56, which is 124. Then I'm going to use my division property of equality to find x. 124 divided by 2 is 62. So x equals 62 degrees. 62 degrees here and 62 degrees here. Okay? Another way you could have done that is you could have just reasoned it out. If I have 56 degrees here and these have to be the same, I know I can take 56 away from 180, and then whatever is left has to be split evenly between these two. So whatever I get, I'm just going to divide in 2, which is what we did. We just did it mathematically. We took 56 away from 180 to see what was left that needed to be split into these two angles. And so then we divided by 2. Okay? We just did it algebraically. All right, number 10, which of the triangles can be proven congruent? Okay, so when I'm looking at this one, I'm going to compare my triangles and see if it lines up with one of my postulates, side, 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 angle, angle, side, angle, side, angle, and hypotenuse leg. Okay, so when I look at my first triangle, I see I have a single tick mark that matches a single tick mark. I have a double tick mark that matches a double tick mark. And I have a triple tick mark that matches a triple tick mark. So that means, remember, when they have the same number of ticks, they have the same length. So I can see all three sides of both triangles are selected. So side, side, side congruence. Yes, I can prove these are congruent using side, side, side congruence. Okay, let's look at the next one. On the next one, I can see I have this angle that's marked on my first triangle, and it matches the angle that's marked on the second one. I have a single tick mark on my first triangle that matches a single tick mark on my second triangle. I have a double that matches a double. So I can see I have two angles and a side. I have two sides and an angle. I just need to figure out, is that angle in between the two sides, or am I going to write it outside the two sides? Because if I'm going to write it outside the two sides, then it's not going to work, because SSA is the same as ASS, and we never trust the booty, right? So to figure out if it's in between or if it's outside, if you place your fingers on it and you highlight the two sides that are the same, when your fingers come together, are they coming together at the angle that we circled? Yes, they are. Yes, they are. Okay, if I had circled that top angle, then when I put my fingers together, it wouldn't be there. And so that would be my SSA. But they do come together where the angle is. So my angle is in between the sides. So this is side, angle, side congruence. Okay, when I look at the next one, I can see I have a single, or actually it's a single arc, but it has three little tick marks on it. And that matches over here, my single arc with my three tiny little tick marks on it. Okay, and then here I have a single arc with two tick marks on it. And here I have a single arc with two tick marks on it. And then I have a segment with a tick mark. and another segment with a tick mark. Okay, so when I look at this, I can see I have two angles and a side. So I just need to decide, is the side, do I write angle, side, angle, or do I write angle, angle, side? Is the side in between the two angles or outside the two angles? Well, same thing here. When I highlight my segments with my finger, when my fingers come together, that's where the angle was, so the angle was in between. If I put my fingers on the two angles, when I bring my fingers together, am I going along the segment that's between those two angles? Yes, I am. So the side is between the two angles, so I put my S here. It's angle, side, angle, congruence. Okay? If I had had my tick mark on this segment here, then when I connected my two angles, I wouldn't be highlighting that segment, and that's how I would know that it was outside. Okay? All right, so this one works by side, side, side. This one works by side, angle, side. This one works by angle, side, angle. So I'm going to circle all of the answers here can be proven congruent to the given triangles. Okay? I have congruent triangles in each one of those circumstances. Okay? Hopefully this has helped you with your isosceles triangles, finding angles, and then also using your postulates. Side, 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 angle, side, angle, side, angle. Don't forget there's also angle, angle, side, and hypotenuse leg. Thank you so much for watching.